Welcome to today's Energy Central webcast entitled, Developing the Security Plan, Protecting the Grid with an Integrated Plan. A few housekeeping notes we would like to mention. If you cannot get adequate sound from your computer speakers, you may dial into the audio portion using the telephone number listed in the right-hand panel of your interface under the audio section. Following the presentation, we will have a brief question and answer session. Please submit your questions at any time using the chat interface on your screen. To kick off today's event, I'm happy to turn the floor over to Rick Schumard, Vice President, Utility Services. Rick, welcome to the event. You have the floor.
Thank you very much, PJ. Welcome everyone to the third in a series of 4 webinar episodes that has been put on by Leidos Engineering in the physical security area. Before we get started into the meat of the topics today, I want to be able to introduce myself and my colleagues who will be the other presenters on this webinar. I'm Vice President for Utility Services at Leidos, and I work primarily with investor-owned utility clients across the country. Prior to coming to Leidos, I spent more than 28 years with the Electric Power Research Institute in advanced technology sales and applications. Joining us once again is Steve Schneider. Steve is our Chief Solutions Architect and Director of Technology Integration for Leidos Engineering. He's responsible for creating new business models that meet complex new business requirements, a perfect example of which being the NERC-CIP physical security regulations. Steve has over 2 decades of investor-owned utility experience. Joining us today is Damon Brady, who has extensive experience in critical infrastructure services, including network design, implementation, and integration processes. He also brings significant experience developing wireless and wireline communication solutions that connect critical components in public safety and security. I mentioned this is the third in a series of 4. Today we'll be talking about developing the grid security plan. Our first webcast on September 28th provided an overview of the Sip14 requirements and the events that led up to the development of those requirements. The October 9th session focused on requirement number 4, which is the assessment of threats, vulnerabilities, and risks to the critical facilities that each utility identified when they complete requirement number 1. Leidos is entering into this discussion because we feel that we offer a unique perspective to utility security. First, we have decades of experience in critical national security infrastructure. We've been performing national security activities since 1969, which include cybersecurity, force protection, and electronic security systems. We also have more than 70 years of utility engineering experience, going back to our heritage from R.W. Beck & Associates and Patrick Energy Services, 2 acquisitions that were made by the former SAIC in the mid-2000s. Additionally, we have performed physical security post 9/11 on airports, seaports, and critical Department of Defense installations. We look at utility security as the convergence of national security into the power and electricity sectors, and our background in this arena gives us a really broad view of the NERC-CIP 14 requirements and the potential evolution of these guidelines. With this brief introduction, I'd like to turn it over to my colleague Steve Schneider to take us a little further into this episode. Steve?
Thanks, Rick. I want to take a few seconds to put the overall SIP 014 intent and activity into perspective. This slide really says it all. We want to either prevent an attack or make sure an attack, like you see on the left-hand side of the screen, doesn't cause a substantial outage in the United States over a wide area. It's really that simple. So everything about SIP 014 is there to ensure that the result shown on the right photo really doesn't happen. And we can really boil SIP 014 down into 4 key questions to be answered. What are your resiliency and security measures? What are your law enforcement contacts and how do you interface with them? What's your implementation timeline, and what is your evolving threat analysis? So Here we can see the 6 requirements defined by NERC that make up the critical infrastructure program. Now today we're talking about requirement 5, which is the development and implementation of the security plan. Now by this time in the process, you should have completed the first 4 requirements, performing your initial assessment of what are your critical facilities, having an independent review of that critical list. If applicable, coordinating between the transmission operator and the transmission owner, and generating a threats and vulnerability analysis of your critical facilities. Now, of course, once you've completed both requirement 4, the threats and vulnerability, and requirements 5, the next step in the process will be validating them with an independent third-party review. So, what is R5? If you looked at R4, which is the threats and vulnerabilities, you can look at that as where the rubber meeting the road. Then R5 really, I look at it as the GPS guidance system to achieve your overall Sip14 compliance. Developing and implementing a documented security plan that covers the utility's critical transformers, substations, and primary control centers. Now, we look at R5 as the holistic consolidation of multiple security components and considerations blended into a single approach. In reality, that's really similar to a utility's reliability program, where we merge pole replacements, vegetation management, cable replacement, wildlife protection initiatives, and other reliability components into a composite overall reliability improvement plan. The security plan in R5 is really the same thing. We're taking various methods and merging them together so that we can detect, delay, defend, and deter the various vulnerability and threat vectors. We look at it as a concise, well-structured plan that will enhance protection and improve deterrence, and most importantly, help strengthen operational effectiveness. And I'll talk a little bit about that later. So what should a utility focus on? Well, we feel that you should focus on using a measured and programmatic approach. And this is important for both the third-party validation process in R6 and also your potential cost recovery via your regulators. You should also be realistic in your timeline and your investment capabilities, and also consider the overall regulator and public-facing component. So let's dive into the basic component fundamentals that your security plan should include. Now, as I mentioned earlier, the plan should address the 4 Ds of security, which is detect, delay, deter, and defend. The plan should also provide actions and measures. And when I say measures, I want to continually stress that. The measures will help you prioritize your responses against your resource constraints. And secondly, really without metrics, you don't know what your plan effectiveness is over time. And also importantly, is your plan drifting over to how the security arena is evolving. Now, we see 4 primary fundamental attributes of cornerstones that really kind of fit into the security element. And their processes, plans, measures, and procedures. People, that's the operations, training, appropriate staffing, call it the change management piece, if you will. Facilities, materials, hardening, fences, and technologies, security systems, applications, cyber components, and tying that in. The overall plan element should be a tool for both your operational and your response protocols. Now, keep in mind it is flexible in the sense that it's a living document, and we do need to assess, update, and periodically refresh our implementation plans. But the most important thing is you got to make sure that you meet or exceed the Sip14 requirements. So in addition to those fundamental components that I just chatted about, what else should a good security plan provide? Or in management talk, how can we drive maximum value into our security solution? So when you're crafting your plan together, again, optimizing it by using a measured and programmatic approach with metrics around it. Also, we know that resources are not infinite, so we need to be able to go out and make sure that the investments that we put in do yield a strong return. As I mentioned before, we want to make sure that we're setting up ourselves to support the case for a strong cost recovery through our regulators. And it really should address resiliency and reliability. And we'll talk a little bit more about that later, but we do know at least one large IOU who has tied resiliency and reliability into the larger security plan and approached their PUC in that manner, and seems to be doing quite well. Cyber should also be wrapped into the mix. Much as SIP14 is about security physically, the cyber component is certainly a two-pronged monster when it comes to security, and we want to make sure that we can address both. And also talking about wrapping human capital in the mix, one of the big takeaways is we really shouldn't make this shelfware in the sense that you put it on the shelf and it sits and you've checked off your SIP14 response. You really should have it part of your overall integrated security operations protocols to be as effective as you can. Now, this slide here shows Leidos' approach to crafting a security plan. So when you're developing a security plan, it is good to base it on a proven risk-based template that governs your approach. And using a proven template helps ensure the program is fundamentally sound and well-structured. Now, we use a model that is based on DHS protocols. And as you can see from the diagram, the model sets up the structure by setting the goals and assessing your systems, catalogs, your networks, looking at risk, prioritization, and effectiveness. And again, having these structures help enable a strong foundation. And while it's important to build an initially foundationally sound plan, it's also vitally important that your plan should have a feedback mechanism in it. Well, why? You want to make sure you want to know as soon as possible if your plan doesn't perform to your expectations. And as I noted several times prior, using metrics and quantifiable data to prioritize and monitor your performance and your cost effectiveness will help you adjust your processes. Plus, it will also help you maximize the ability to reach your security programs by ensuring your program is not drifting. Now, in this plan, we actually look at three threads that go throughout putting it together, which is the physical security component, the cyber component, and the human element to it, which really kind of boils down into change management. And in the next few slides, Damon and I are going to dive into how we integrate the cyber, the physical, and the human elements into our security plan. Michael and Dwight, now here's some of management's better representation, and they're in the midst of a classical problem, which is protecting their silos. And so how many times have we seen IT clashing with OT and security and operations kind of looking over the table to each other, or the engineers and the field personnel kind of looking at a print across the hood of a bucket truck and trying to figure each other out? These silos are everywhere, and they often cause a well-designed plan or program to fail. And so we got to avoid this classic pitfall when we're crafting our response, especially since SIP14 really centers around a major national security issue of ensuring the grid remains up and stable. So as I mentioned, getting everyone together has been historically difficult, and when you're putting your plan together, you really should try and break down those silos as much as possible. Now, in this diagram you see here, that we see the plan really crossing over engineering, OT, IT, and security. And it's really important because if you don't cross those four silos and integrate them, you're really not grabbing the full capability of the utility to be able to address the singular program. So, engineering, OT, IT, security, it's important to have all those wrap into a singular unit. So a couple of slides ago, I noted that SIP14 could be boiled down into the four key questions you see on the left-hand side of the screen. Now, when we're looking at those four questions, there's a series of elements that we look at to address those, and they can include facilities and infrastructure and system and equipment, your physical hardening and your capabilities, your policies, your guidelines, your measures, your procedures, your staffing, your contingency and response plans, your communications, your external responses, your training. There's 20 or so lists or elements that we integrate into those. But if you really look when you're addressing those, we can wrap all those multiple elements into really 4 foundational cornerstones, which are people, processes, facilities, and technologies. And I wanted to cue that up because Damon Brady now is going to take us through a nice detailed discussion on how we use these cornerstones and the elements of the cornerstones leading to a robust security plan. Damon?
Yeah, thanks, Steve. I'd like to take a few minutes to elaborate a bit more on what we view are the key cornerstones of a Sip14 compliant utility security plan, and talk a little bit about how they work together to create a robust best practices security posture. So I don't know if it's because I'm a big fan of the TV show Game of Thrones, or maybe it's because our cybersecurity team routinely comments on some of the siege tactics of cyber warfare against critical infrastructure. But the idea of a capsule analogy came to mind when trying to articulate how the people, processes, facilities, and technology, or tools, are critical foundational components that depend on one another for the overall strength of a comprehensive utility security plan. Weakness in or a lack of coordination between any of these cornerstones can lead to structural issues in your castle, so to speak, exposing those vulnerabilities and leading to a less than optimized security posture. With each of these cornerstones really well thought out, though, infrastructure will be strengthened, and it can resist and repel many of the cannonballs that may be thrown at it from any number of physical threat vectors, whether they be internal, external, whether they're cyber or physical. I'd like to thank our graphics department for the nice use of cannonballs there, too, representing our threats. In the next few slides, I'll try to address each of these cornerstones in a little bit more detail, and try to give you some thoughts around how you can address each of these areas to develop a security plan that not only takes care of your Sip14 requirements, but also provides tangible benefits to your overall security posture. So let's start with people. People's probably the most fundamental and highly variable of the cornerstones we'll talk about today. So when you're developing your security plan, there are a number of things you need to consider. From a staffing perspective, consider your core staffing. Who do you have? Who do you need on the team from a surveillance operator perspective, guard response perspective, investigator, administration? And look at what skills need to be augmented. In many cases, and more, support staff are required. And those support staff really need to come from other silos. IT for networks and cybersecurity, OT for situational awareness and grid resiliency, and O&M for facility access and component maintenance. Also need to take a look at what duties these staff are going to be performing and how often. Is the staffing plan sufficient to handle day-to-day operations? Most of the time we are operating in just day-to-day status. But what about when critical incident and disaster operations happen and the DOT has to be active? What are the performance and response metrics that are in place to assure that you've got a competent, quality, and focused execution? One real-world example where we've observed an issue is we have a client who was receiving 3,000 to 5,000 alarms per day to their security control center, and they only had 4 staff to process them. So, we had staff essentially handling between 800 and 1,100 alarms per day. Hard to do that. Also look at what's the relationship between utility and law enforcement. They play an important response role for most utilities. There's criteria for response time and prioritization need to be addressed as you complete your threat and vulnerability assessment. And what is their response capability? And how do you shape your plan based on limitations should they exist? Look at training, rigorous and recurring training. Development of that plan based on response performance metrics is very, very important. And do that for both normal and unusual operations scenarios. And finally, engaging with the regulators. Make sure there's an ongoing dialogue from that perspective. Enforce frequent communications that really help drive best practices and assist in overall situational awareness. If you can convey those key successes, where you're seeing best practices take hold and operational efficiencies realized, you can build collaboration and trust and often influence the regulatory environment. Next, let's talk about process a little bit. You can have the highest caliber staff, but if they're not working in concert with a robust set of policies, processes, and procedures, it can be pretty impossible to realize the full benefit of their capabilities. And not to mention that regulators are going to want some level of confidence, knowing that you have the processes in place not only to operate, but also to maintain and evolve on an ongoing basis your Sip14 compliance security plan. So a quick warning. It can be very easy to get lost in analysis paralysis when talking about processes and there can be an infinite set of variables that security staff have to handle. The key is the keep it simple model works well here. Focus on the key elements you've discovered in your R4 TVA, the threat vulnerability assessment. Prioritize the processes associated with those, and you're well on your way. A few relevant process areas that should be addressed: response and event management. This is a given, obviously, and it's a critical portion of the security plan processes. The team needs to have clear, concise, and relevant instructions for handling the variety of events that can and will crop up, and really needs to address both the business as usual and threat attack scenarios. Here's another real-world example for you. One of our critical infrastructure customers operated a facility with a very large fence line. Gosh, they were probably fencing in 1,200 to 1,500 acres. To support monitoring, they developed a state-of-the-art PIG system and deployed it. The system worked flawlessly, transmitted alarms. Those alarms were received and acknowledged by their SOC. Unfortunately, there was a process and procedure gap in place for deploying an effective triage system in response to those alarms. They were simply acknowledged, and because of the lack of that process, the staff waited to see if there was a false alarm or nuisance alarm, or whether another facility alarm, like a door force, for example, got triggered. You can see that a process break there can lead to some inefficient security plans. Along those lines, to help fix that, define metrics to define success. What are acceptable response times for acknowledging, triaging, initiating response times? At what point does a recurring alarm trigger investigation into whether it's a nuisance alarm? Also, watch law enforcement response times. Those are all things in a plan from a metrics collection perspective that are valuable. On a related note, tracking that effectiveness through action reviews is an important step in getting feedback for improvement. It also promotes stakeholder and staff engagement and really helps facilitate that overall situational awareness. Finally, configuration and change management. Yeah, this process can be new or part of an existing operational CM process, but it's very, very important to try and track those processes and integrate those with your CM process. The challenge here is making the CM a support mechanism and not allowing it to become a barrier or obstacle to moving forward. But it's important to ensure that any significant changes in your cornerstones are understood and impacts are understood, both positive or negative, and that they're accounted for. So one of the common pitfalls for process is that it becomes stale, or it becomes obsolete, and the result then is that they become incorrect and security response is compromised. So one way to mitigate that risk is to have a life cycle management or evolution plan. And each of the cornerstones we're discussing today is evolving so rapidly in response to that continuing threat landscape out there, that changing threat landscape out there, that planning that life cycle evolution really allows effective and thoughtful cornerstone upgrade and in a position to react dynamically with threats, budgets, and other constraints for this. All right, let's move on to facilities a little bit. Hardening and protection of facilities. I think this is probably where the rubber meets the road and much of the money is getting spent. The thing that people see and is really key for that, for the deterrence and detection and delay, et cetera. Yeah, in Sip14, it means those critical assets and interconnect points that could impact grid stability. And initially, it seems that it's a relatively straightforward problem. Define a standard hardening scheme and deploy it at all facilities. The reality, though, is it's a much more complex issue than just throwing up higher and thicker walls. That's clearly part of the answer, but it's not the only answer. The reality is that most cases face a site reality that precludes a lot of standardization beyond anything more than a toolkit of available tools. And this is due to broad differences in geography, topography, locale, population, density, law enforcement, coverage, and response capability. Big difference between a substation crammed into a clover leaf on a major interstate and a substation located in a remote forested area. Success in this cornerstone to me can really be defined sort of determining the best blend of protection systems that really maximize the utility's ability to deter, detect, guide, delay, defend. And some of the key ingredients in formulating this recipe, if you will, are walls and barriers. Yep, you do need them. What types, how high, those are all dependent on a number of factors, public safety versus threat vectors, et cetera. Surveillance and detection, selection of these sorts of technologies is largely dependent on what type of response can be mounted and what is that surveillance being used for. Is it being used for detection and response, or is it being used primarily for forensics after the fact? Those are important things to understand in the context of your substation environment. Response with guards and law enforcement. In many cases, law enforcement can't provide adequate responses, or it's low on their priority list. There's a lot of other criminal activity going on out there. Does the site warrant private guard patrol or dispatch? I had one utility ask me a question: how do they protect a critical asset with law enforcement that could have a minimum 3-hour response time? And that's if it's not a Friday night and the sheriff's son isn't playing in the high school football game. So those are all factors to consider. Countermeasures and resiliency, planning for countermeasures, ranging from lights and sirens to more extreme solutions, are all important. And in most cases, developing strategies for improved resiliency in the face of attack are important and are likely to be implemented. Again, designing the facility hardening approaches requires a standardization of systems to a degree, but never neglecting the individual site realities present at most locations. And those all start to shake out as you conduct your TBA. Moving along to technology. Last of our security plan cornerstone centers on technology subsystems. Technology tools can be used to enhance the detection and surveillance capability. They can improve deterrence and denial of access. They can act as force multipliers, speed triage and response times, but also they can correlate events and enhance overall situational awareness and really facilitate cross-operational comms. These technologies both include physical and digital and extend across security operations and incorporate elements from other operations as well. What are some examples? Examples could include OMS integration, information, network monitoring data, cybersecurity data, and some of the major physical security technologies that will be likely addressed in your Sip14 security plan include a bunch of the field and control center components. So we're looking at transformer shrouding. That's one technology, and other ballistic detection technologies and defenses that can play a valuable role. And on the more digital side of things, access control systems. More and more facilities are moving away from key core locks out at their field, in their field assets to digital access control systems. And these obviously have a number of benefits in that they provide more traceability, more accountability, and administration capability to address both external but also internal threats and respond to those quickly. Video management systems. In many remote use cases, legacy CCTV systems have been largely inadequate for supporting detection and response coordination, and even after the fact forensics. One client recently experienced a substation break-in. Their PID system detected a fence compromise, but the cameras were unable to capture anything more than a few blurry, kind of shadowy images. Updated systems now have an ability to employ night vision and video analytics capabilities that not only help sort and correlate events more effectively, but improve detection capability dramatically. Perimeter intrusion detection is another one that's worth mentioning. They're notorious for having false positives. We talked about a couple examples of that today where operators simply ignore alarms because of it. But they've also improved dramatically in recent times, and when combined with video analytics, would be just a great detection capability and really jumpstart response times and implementation of deterrence measures. They can also shape the level of hardening for some of your more construction-related systems. Networks, something that should be addressed in any technology discussion. The goal of extending the reach and capability of the FCC or SOC is heavily dependent upon the ability to acquire information from remote assets. As such, network resiliency, redundancy, capacity, cybersecurity all need to be considered to ensure that data is captured and transmitted and received accurately. And as new field instrumentation is deployed, you're getting more and more information. So the volume of information is growing exponentially. And while simply adding more staff to ingest it all may be the answer, employing a PSAM or physical security information manager or SIEM capability can greatly reduce that workload, increase operational efficiency, and really help drive through some of the processes through event correlation and allow operators to respond more quickly. So in addition to these core technologies that I've described, there are a number of other opportunities to enhance the effectiveness of your security plan. We'll talk about some of them more, I guess, in upcoming episode 4 of this webinar series. But things like open source intelligence from government sources and other utilities can really help enhance situational awareness, especially when you're talking about interconnect systems and the impact from others. And it can really help bring new context to security events being tracked within your infrastructure. Similarly, data analytics are being applied more and more. And while Sip14 won't necessarily be looking for a data analytics strategy, it'll become an increasingly important tool in identifying and eventually predicting trends that could impact your security posture and drive improvement. And last but not least, there's an incredible opportunity to take advantage of low-hanging fruit on the tree as a result of IT/OT conversion. Easier than ever nowadays to correlate key system events. Those that are important to individual silos, but not necessarily to all, and determine whether the overall organization is at risk. Classic example is the correlation of remote door alarms with network outage and cyber attacks. We've seen this happen more than once where remote sites have been used as entry points for network disruption or cyber attacks on either SCADA or enterprise network systems. So try to begin to conceptualize how enhanced situational awareness and sharing between functional areas, both between your operational silos and public safety and first responders, can lead to an overall process optimization. All right, so how do you apply some of this domain expertise? I've provided a few details regarding some of the elements that should be considered in each of our 4 cornerstones. By now, it's pretty obvious, establishing a strong security posture in each of these areas requires a broad set of capabilities that reaches across disciplines well beyond traditional security. These are essentially the bricks and mortar, let's say, that support the cornerstone towers. And applying these disciplines in a thoughtful, judicious manner to make your plan as strong as possible is really a challenge, but it's something that Sip14 tries to address. Our approach, we like to start with defining the mission or the CONOPS and then working back from there through the field. And so really starting with that CONOPS and business process management, figuring out how your security infrastructure and support staff can change. Looking at the physical security systems, what tools add the most value, help reduce risk the most in conjunction with your PBA. Look at hardening and construction. What's viable and what's practical? Where do you get the bang for your buck? Assessing network and cybersecurity, ensuring information availability and accuracy, and integrating communications to other operations and externally, and taking advantage of some of those external sources for OSINT, for example, EMT, GIC, sort of things that operational areas look forward to. All these elements really need to come together in a cohesive fashion to achieve your Sip14 compliant plan. Oh, I should mention also, consider logistics and supply chain management part of that. That's an important piece to assuring overall resiliency. So how do all these capabilities get pulled together into a cohesive plan? We like to use a modified kind of SIPOC type approach. Takes key functional areas and applies them using the risk-based framework that Steve described earlier to each of our cornerstones. External inputs also play a role in the development of the security plan. And once completed, this requires a bit of iteration rather. But once completed, you get a solid security plan that's not only compliant, but it's actionable. It'll be something that can become a key element in your security strategy on a go-forward basis, and really help you to deliver things like assurance around facilities and infrastructure, confident selection of systems and equipment, your physical security hardening guidelines and metrics, and then it really gives you the policies and guidelines, the measures and procedures that help you to implement and take the most advantage of those hardening and technology systems, and provide your staff and human resources the confidence with appropriate contingency and response plans. Finally, it helps with communications, both internal and external, coordinating external response and also public-facing communications. And it really starts to set you up with a guideline for having a recurring training process whereby this iterates and evolves, and your operators are able to, and your staff at large really are able to take advantage and participate in the security plan. So with that, I'm going to transition back to Steve, who's going to talk a little bit about implementing that plan and some of the timelines involved.
Sounds good. Thanks, Damon. Hey, I understand that some of the attendees have noticed that Damon's phone quality was a little variable. So if you do have any questions, feel free to reach out to us. We'll have contact information at the back of the slide deck in which we can, get with you one-on-one on a question and answer session if you some of that was muffled or you wanted some more detail. So with that said, as of today, the SIP guidelines, or the Sip14 guidelines, have not been officially released from NERC yet. Now that said, the official timeline does start when the guidelines do drop. Now per Sip14, the security implementation plan should be written or formed within 120 days after the third-party review for your R1, which is your critical list. Now, that doesn't mean that you need to be done implementing the security actions you ID'd in your threats and vulnerability analysis and your security plan within that 100-day time. It's our opinion that about a 2 to a 3 year time frame is reasonable to accomplish your security plan. Now, of course, input from your regulators may impact that security timeline. Now, also, as I noted in an early webinar I did, we know that not all critical substations and control centers are created equally. So, as such, your timeline will take that prioritized criticality into account when you put your implementation timeline together. It's also important to know that the threats and vulnerabilities will continue to evolve and change. Now, just like the TSA at the airport, we originally started from metal detectors and we went to shoe removal, and now we're in the full body scanning for gels. You should expect your security protocols to change over time. So as a result, those changes may also impact your implementation timeline and prioritization. Also, your R6 auditor or your third-party independent review will also have input into your schedule. Now that said, even though the NERC Sip14 guideline hasn't dropped yet, that's not to say you really shouldn't go out and start, planning accordingly. It's our opinion. We think that the final NERC Sip14 draft is not going to be that substantially different from the bottom line one that finally does come out. So getting a head start certainly doesn't hurt. Now, it's important when you're putting any program together that you ensure effectiveness. And as I mentioned before, having a feedback loop is really critical to ensuring your security program meets or exceeds its goals. So how do we actually gauge effectiveness? So one easy one is just like performing storm drills for your utility lets you see how your storm response is and do you have any weaknesses. Tabletop exercises and potentially full-scale field exercises will allow us to help gauge our responses to the security aspect. So training drills and field exercises, we believe, should be incorporated into your security plan. Establishing scorecard metrics for response times, staffing, expertise levels do provide a quantifiable yardstick. And Damon did in his slides mention a couple of the metrics that he is incorporating into the overall security plan. Be aware that technology will change, and this applies to really both what the utility has as countermeasures and what your adversary has as threat attacks. So as such, the plan should include periodic surveys of the most recent threats, vulnerabilities, etc. You should take into account tech refreshes and life cycles of your technology, and continually refreshing the plan so it incorporates those threats and countermeasures and technology improvements, make your plan that much more effective. So for the last 45 minutes or so, Damon and I have discussed considerations for your security plan. The high-level takeaway is a robust security plan really needs to take all of these potential resources and thought processes and silos and integrate them into a singular plan. We talked about the threats and vulnerabilities through R4. Looking at the newspaper, looking at what's happening in our industry, we know that cybersecurity and physical security are converging. So the effective security plan is going to need to account for both of those. First responder coordination. How robust is your first responder coordination? Are they proactive or are they reactive? How do you tie into them? What's their strengths and weaknesses? What's the response times? Do you potentially need supplemental, manpower for guarding and/or response? Engineering, tying in multiple aspects into security, resiliency, reliability. You can actually create your engineering at the front end so it incorporates multiple aspects. And there's you can tie that into a higher operational excellence and operational efficiency for the utility makes sense. We know we all have constrained resources, so being able to balance those against prioritization, training, the human element, the change management, the responses, and then finally policies, procedures, and processes. They all really need to blend together to create the robust plan. There are other avenues or resources, but these are some of the more common ones you should contemplate. Plus, you also need to look at your specific utility configuration and for what is unique for you, ensure that if you have unique needs and or security issues, they're tied into it from there. Now, with that said, I wanted to hand it back over to Rick Schumart, who will round us out and give us some important information on the tail end. Rick?
Thanks, Steve. I appreciate it. Before we begin the question and answer part of today's presentation, I'd like to take just a minute or so to invite you to continue to join us for the fourth and final session of our webcast series, which is scheduled for November 6th. In the past 3 sessions, we discussed how to meet the letter of NERC SIP requirements. In our final session, we discussed ways to capitalize on that effort and increase the value to your utility. These include applying big data and data analytics to the new security-related information streams that you'll have access to, taking advantage of process updates to effectively share and correlate IT and OT information, leveraging new physical security technologies and tools to go beyond SIP compliance and include other utility assets, taking advantage of the efficiencies you've put in place and applying those new technologies thoughtfully. Also incorporating grid resiliency and leveraging openly available open source intelligence. A couple of topics we haven't talked a lot about are electromagnetic pulses, or EMP, and geomagnetically induced currents, GIC. A number of utilities are looking at one or both of those as part and parcel to their physical security plans. Damon mentioned the importance of supply chain coordination and cooperation, and the stress tests and drills for continuing effectiveness are really important for keeping you sharp and on point. Basically, you need to be thinking about doing what's right for the utility, not just what makes us SIP compliant. What you see on the last slide here is contact information for the 3 of us. You can reach us by phone, email, any way you want to, and we'll get back to you as quickly as we can. We always get a number of follow-up questions and requests after these episodes. And then at the bottom, you'll see the link for getting a copy of today's presentation. At this point, I would like to go into the question and answer session, and we'll see if we can take care of some of those for you. The first question we have submitted is, please give us examples of the measures you spoke of in slide number 9, which was R5 Physical Security Plan Elements, which provides measures for detection, delay, deterrence, and defense. Damon, your thoughts on that?
Sure. I apologize for any voice quality on this call, but I'll do my best to try and respond. Measures for detection, delay, deterrence, and defense are really variable based upon the 4 cornerstones that we discussed in more depth. They can range from the physical hardening related to walls and barriers. Many companies are now deploying ballistic systems to protect key substation assets from physical threats and shots fired. They can include technology systems. Perimeter intrusion detection systems, for example, are very good ways for detecting and providing perimeter intrusion alerts so that you can start to deploy a response. From a delay perspective, people are using things like obscuration, where they're using They're using vegetation and things to actually start to help provide a delay barrier for approaching the perimeter. Deterrence, obviously, those are where you put on your it could be signage, it could be lights, a number of things related to deterrence. And then defense, that's where we obviously start to look at locks. We can look at any number of defense mechanisms, whether they be cyber or whether they be physical, from protecting and preventing access to the facility. So it's really about shaping what those four cornerstones are and how they're applied to each of the facilities and what the response shapes are. I hope that starts to answer some of that.
Thanks, Damon. Steve, I know you have some thoughts on the metrics around this issue.
Sure, absolutely. So, I mean, there's metrics such as, well, what are the acceptable response times for acknowledging triaging? How many false alarms do you have? What's the law enforcement response time? What's the a physical time to actually penetrate my barrier, be it a fence? How many alerts per operator in your system? What's your response time? So those, similar to what you see in a storm drill, it can be certainly applied to the metrics. And they're also, you can look at, because security in its own mind is, you can have some nebulous metrics in a sense of, well, if nothing happens, am I being successful, or did nobody try and penetrate me? On the cyber side, again, there's significant amounts of attacks to your firewall, corrupted passwords or whatever that you can incorporate into the cyber component to that also. So keeping in mind that the overall composite plan is both a cyber and a physical response. Hopefully that answers some of those questions, but you can get a lot of time cycles, responses, failure rates, and incorporate them into determining whether your plan's drifting or effective or not.
Thanks, Steve. The second question we have is it desirable to designate a Sip14 coordinator for the effort within a company? Our position is, yeah, that's probably very desirable, but whether that coordinator takes the form of a single individual or a committee, a work group, whatever, is probably going to be utility specific. There's no one way that is better than another. It's whatever the utility is used to using in coming together to address these kinds of issues. What we've seen with the utilities that we've worked with so far is there is usually some kind of a committee or task force that addresses this with an obvious leader there that tends to function as the point of contact between that company and other outside entities, whether those be outside engineering providers, regulatory agencies, law enforcement, and then their policies and procedures that Damon talked a lot about tend to delegate some of that stuff as well. So there's no one solution for it. You just need to decide what you're going to do for yourselves. Damon, do you have any additional thoughts on that?
Rick, I think you've covered it. I think you've covered it exactly right. It's definitely something that requires both. It requires some thoughtful organization and really a champion to drive effectiveness. And I think you've covered it.
Okay, thanks. Let's see. Question number 3. The question regards slides 12 and 13, the operational silos. That's sort of what we were alluding to in the last question answer. My synthesis is an operational one concerning the soft stuff, the humans and the processes, and hard stuff, the technologies and hardwares. How hard is the soft stuff? In other words, how did you manage the reluctance from rather senior people to accept and train themselves towards hard stuff in the smart grid revolution? Steve, you have some thoughts on that?
Yeah, thanks, Rick. So first of all, that change management or the soft stuff can truly be some of the most difficult elements to putting any plan together in there. So I guess the first thing is obviously that the NERC FERC requirements will be a utility requirement to address those. And the fact that it is a large requirement, the sea level is uniquely aware of what that is. Now, there are a couple ways that you can do that. One is that, and in different utilities, the security realm is run out of different areas. We've seen it where it's run out of the CIO area. We've seen it where it's run out of corporate security. We've seen where it's run out of transmission and engineering. So the actual landing spot of the individual utility where it comes from is again, as Rick had mentioned, variable to the utility. There's a couple things that we do that can heighten that. One is that particularly around the cyber component, getting your CIO to understand what are the threat vectors associated with cyber is important. But the overall perspective of that, and that's a difficult one, and truthfully that's going to be uniquely constrained for each utility, is the fact that bringing the team together and mentioning that it is indeed a FERC requirement through NERC, and that the utility can see some substantial issues if they don't have adherence to that. And then working it from that end is it's a federal edict, and then getting the sea level together to ensure a proper plan. That was a very nebulous response because again each utility is different, but having the overall importance of what Sip14 is and how it has potential impacts is probably the first step to doing that.
Thanks, Steve. Our next question is, why did the speaker say companies are getting away from card reader access? And I didn't hear what he said was replacing those readers. Damon, I think that was in your area. You care to address that?
Sure. Yeah, and I apologize. It's probably the voice quality that was getting in the way there. But I'm not suggesting that at all. What people are getting away from is the traditional key cores that used to get issued and would sit on a key ring. And so getting away from the traditional locking keys in favor of digital access control systems. And the real value to that is being able to know exactly who's accessing the facility and when. That helps from both an external and an internal threat identification perspective, and it also greatly enhances the ability to quickly take care of internal threat mitigation from rogue employees or terminated employees, et cetera. So I know people are moving toward remote deployment of digital access control systems, and a lot of that's being driven by improvements in the network connectivity and an increased degree of confidence that digital access control systems can effectively work at remote locations, even in cases where there is limited network connectivity.
Thanks, Damon. The next question is, on the cyber side, with the push for the smart grid and open protocols, do you feel more emphasis should be placed on the cyber side of the initiative? I'd like for Damon to address that first, and then Steve has some thoughts, I believe, on that as well.
Okay. Yes, cyber is an important part of any plan, whether it be Sip14, and Sip14 should have a cyber component, but recognize also that there are significant cyber components in overall SIP-V5 that are being addressed. My viewpoint is, if you look at it back from that castle analogy, if you've got your substation infrastructure that's out there, from a network perspective, for years and years, the cyber defense really started at the data center or at the enterprise level. And now more and more that cyber infrastructure, that network infrastructure is being deployed in the field, whether it's at a substation or at a pole top, in O&M vehicles. The network systems are becoming much, much more porous and accessible to external influences. So cyber does need to be very well thought out. It needs to be part of the Sip14 initiative, but it also needs to tie back into the the bigger picture SIP-v5 sorts of things that are going on. And so addressing it in that context is my view on how that can be approached. It's important from a SIP14 perspective because cyber awareness in the construct of physical security operations and operations management can help a lot in assessing situations and triaging situations and providing event correlation, as well as determining response based upon any potential cyber impact. So definitely an important component, should be given plenty of emphasis. Don't reinvent the wheel, though, when it's being covered off on in other areas. Make it complementary in your SIP14 plan. Steve, did you have anything you wanted to add on that?
I do, thank you. Yeah, so taking a step back, realizing SIP14 is about ensuring that an attack does not cause a significant stability or cascading failure effect on the transmission system. So I know the question was about AMI and smart grid. So the lens of looking at cyber under a SIP14 is ensuring that you're not causing a substantial catastrophic cascading failure. So the cyber component should be addressed toward ensuring that your control centers and your substations are protected. The AMI, the distribution feeders and all that are important, but you have to temper that by knowing what the overall SIP component, the impact of that is. Now that said, the cyber piece, SIP14 is about physical security, but I believe, it's my opinion that a robust security plan needs to address both the cyber component, or if you will, almost a mind meld between the, as Damon mentioned, the SIP version 5 and the R14 to be able to basically ensure you can do a two-pronged defense against the entire, defense threats and vulnerabilities universe.
Great, thanks, guys. Next question. You mentioned a few entities who are having success in this area. Are there any available or published case studies on their success? What's working well, etc.? Steve, why don't you make some brief comments on that, and I'll bring up the end on that.
Sure. So the interesting concept of that is that most utilities don't want their security plans openly laid out in front of everybody because of the ability to potentially either take advantage of them or it just wouldn't be appropriate with regards to the security spectrum. So there are not a lot of case studies that are open out there that you can open book and read. Now that said, at a high level, what we have seen is that there have been a utility that has combined resiliency and security together. A lot of the utilities are diving into the SIP14 initially with pilots so that they get an understanding of what's going on prior to the SIP dropping, and then using that as learning experiences to go back and improve their overall macro SIP14 responses from there. Again, the utility spectrum has seen everything from somebody who's way out in front to some people who are doing pilots to some people who are just sitting back and gathering information. But as a whole, though, again, opening up the security plan for a utility probably won't happen. Rick, I don't know if you have a perspective on that.
No, I think you covered that well. I was going to make a couple of those points, but that's fine. The final question, who should be responsible for running the program? We actually sort of addressed most of that in an earlier question. It's going to vary from company to company. Sometimes it's on the operational side of the company, occasionally out of the transmission control center. Sometimes it's on the IT side. Sometimes it's out of the corporate security area, which deals with far more than just physical security and cyber security. So there's no one answer for that. The answer is whatever works best in your utility based upon how you are organized that allows you to transcend the silo structures inside your organization. You need resources from all of those silos to pull together and harness to be successful in this. Okay, I think that brings us to an end for today. I'd like to hand the meeting back to PJ.
Thank you, Rick. And for those who we didn't have time to get your questions, we'll do our best to follow up with you offline. For our audience, we hope you've enjoyed today's discussion. As you log off, please take a moment to complete our survey and give us your feedback so we can continue to provide you with quality content. Thank you for attending, and this does conclude today's presentation.